Hi, I am Jomar Indirit. Our topic for today is alcohol. In chemistry, alcohol is an organic compound that carries at least one hydroxyl functional group bound to a saturated carbon atom. The term alcohol is originally referred to the primary alcohol, which is ethanol, which is used in a drug and the main alcohol present in alcohol drink. Using the IUPAC system, the name for the alcohol uses the OL suffix with the name of the parent alkane together with the number location of hydroxyl group. The name longest carbon chain that contains carbon atom bearing the OH group, drop the final E from the alkane name and the add suffix OL. Saan natin mas matatagpuan kadalasan yung alcohol? Minsan makikita natin siya sa animal tissues. So saan natin makikita kadalasan yung alcohol? Or saan natin kadalasan matatagpuan alcohol? Kadalasan natin makikita or matatagpuan yung alcohol in the animal tissues. Example is extracted from the fish oil are example of naturally occurring sources of alcohol. For the non-beverage uses of alcohol is more commonly prepared by passing ethylene gas in high, high pressure into concentrated sulfuric or phosphoric acid from the corresponding ester. The acid ester mixture is diluted with the water and heated forming ethanol by hydrolysis and alcohol then removed from the mixtures. The alcohol can be produced in alkane by hydration. With boiling water gives alcohol by reducting of aldehyde.
This is typically shown as ROH, where R means the rest of the molecule and OH is your alcohol functional group. Since alcohol is a high priority functional group, you will add the letters OL as a suffix to your molecule. Starting with this example, we highlight the parent chain and number so that the OH gets the lowest possible number. In this case, we have 5 carbons giving me a first name of pent. We have only single bonds giving me a last name of ane. Since the alcohol occurs on carbon 2, we add the prefix 2-ol. When putting the name together, you can bring the 2 to the front of the name, and that means ol will directly follow ane, and so you drop the e. This gives me a final name of 2-pentanol, where it's an instead of aneol. When you have a substituent on your alcohol, you still follow the same rules where your substituent becomes the prefix and the alcohol is your suffix. You may recognize this molecule as having the common name tert-butyl alcohol, but let's see how to name it using the IUPAC rules. We'll start by identifying and highlighting our longest carbon chain, in this case is 3 carbons, and numbering so that alcohol gets the lowest number. We have the option of numbering both from the right and the left, each giving oxygen a number 2, so I'll start numbering from the left. Having 3 carbons in my parent chain gives me a first name of prop. Having only single bonds gives me a last name of ane. Since the alcohol is on carbon 2, I have a suffix of 2-ol. And since the methyl is also on carbon 2, I get a prefix of 2-methyl. Putting the name together, remember that the prefix goes first, then the first name, then the last name, then the suffix. Remember to drop the e from ane for a final name of 2-methyl 2-propanol. The rules for naming a cyclic alcohol are just like straight-chain alcohols, where you start by identifying the parent chain, in this case a total of 5 carbons for a first name of pent. Given that the molecule is a ring, I add the prefix cyclo. Only single bonds gives me a last name of ane. Since alcohol is the only group on the molecule, I give it a number 1, and then choose to go clockwise or counterclockwise for a total of 5. The alcohol would give me a suffix of 1-ol. However, since it's the only group on the molecule, the number 1 is understood and does not have to be included. This gives me a final name of cyclopentanol. A diol is a compound that has 2 OH groups on the same molecule, and we'll use this as an example. My parent chain has a total of 6 carbons in a ring. That gives me a first name of hex and a prefix of cyclo. Only single bonds gives me a last name of ane. Since this is a symmetrical molecule, I can choose to number from either direction as long as one OH group gets number 1 and the second one gets number 2. I will write 1, 2 to show which carbons the OH groups show up on, and then I will put di in front of the OL to show that I have 2 alcohols. Putting the name together, I get 1,2-cyclohexanediol. Notice that I did not drop my E in this case, given that I have the consonant D in between 2 vowels. Let's try an example with the pi bond. Identifying my parent chain, I see that I have a total of 5 carbons. If I number from the right, I give my pi bond the number 2. If I number from the left, I give the alcohol a 2. Since the alcohol is higher priority than the pi bond, I number from the right for a total of 5 carbons, giving me a first name of pent. Having a pi bond on carbon 3 gives me a last name of 3-ene. Having an OH on carbon 2 gives me a suffix of 2-ol. Putting the name together, I get 3-pentene-2-ol. Notice again that I did not drop the E, and that's because I have the number 2 separating the 2 vowels. Let's try something tricky for the final problem. In this case, I have 2 rings fused together, so I have to go back to the rules of naming bicyclic compounds. I start numbering from the bridgehead closest to the OH group, since that's my highest priority, giving it a number 1, and then follow my way around the ring that has the OH, continuing around the ring that has the bromine, and then jumping to the bridge carbon that has nothing on it. Having 7 carbons in my parent chain gives me a first name of hept. Having only single bonds gives me a last name of ane. Since I have 2 fused rings, I have to precede with the word bicyclo, and then I have to include how many carbons are unique to each ring.